In the year 1867, Sir Isaac Newton published his universal theory for gravitation. Legend has it he came up with the idea when he saw an apple falling from a tree one day. Now, there's a big leap between watching a falling fruit and coming up with an equation. It's an intellectual pursuit that is difficult, time-consuming, and not very glamorous. See, the world around us is filled with beautiful patterns and regularity, and we depend upon mathematical equations to explain these patterns to us. But where do these equations come from? In Isaac Newton's case, he had some background theory to build off of. But in lots of other cases, all we have is the information we get from our data that we measure in our experiments. Now, it's really tricky to fit an equation to a data set. It's even more tricky if you don't know what your equation is supposed to look like. Are there products? Are there sine waves? Are logarithms involved? It's kind of like trying to find your keys, except you don't know which room of the house they're in, and you don't even remember what they look like. What if we could automate this process of coming up with equations to fit our data tables? This is the task of symbolic regression. It's explosively difficult, and we don't really have a good way of solving it yet. The most popular method used today is based on something called genetic programming. It works sometimes, but it's clunky and unreliable. Also, it's decades old, which basically makes it a dinosaur in today's rapidly evolving world of data science. It's time for an upgrade. In my research, I'm trying to improve the approach we have to symbolic regression. I want to take advantage of the fact that we have access to all sorts of machine learning advancements that weren't available even 5 years ago. I'm working on a method that learns from its own experiences, kind of like how you and I do every day. Every time it makes a guess at an equation, it checks how well it did and adjusts itself so it can improve on all of its future guesses. It sounds pretty good, but it's still not good enough. See, if the starting guesses are too far off, it's not going to go very far further. That's why I'm proposing to use a second machine learning model, a deep neural network, to help us out. Now, neural nets are powerhouses with all sorts of applications. I've designed one that helps us produce strong starting guesses on what the winning equation might be. So it all comes down to this. The universe is filled with beautiful patterns. We need equations to teach us what those patterns are. We use a symbolic regressor to teach us what the equations are, and now we can use neural networks to teach us how to train our symbolic regressors. And today, I'm teaching you how all of this fits together into a system that can accelerate scientific discovery. Thank you.